Hi, hearty welcome to you. We are solving some examples as part of inverse trigonometric functions. So let's go ahead and solve them. So the first one is sine inverse of sine 33 pi by 7. We have to evaluate the value of this. Now we know that if the trigonometric function has to have an inverse function, then the domain should be between minus pi by 2 to pi by 2 for sine. So the value of 33 by 7 is cannot be used when you want to apply sine inverse. So this should be converted into an angle which is between minus pi by 2 to pi by 2. So let's try to simplify this. So I can write it as sine inverse of, now I see that 33 pi by 7, I can write it as sine 4 pi plus 5 pi by 7. This is nothing but sine inverse of. Now you know that the period of sine is 2 pi. 2 pi into 2 is 4 pi. So the value of 5 pi by 7, it will be 4 pi plus 5 pi by 7. That means after 2 pi it will be reset to 0. So this becomes 5 pi by 7 because 2 pi is the period. So what we are saying is whether you take 5 pi by 7 or you take 4 pi plus 5 pi by 7, the value of the sine function will be the same. So I can write it as 5 pi by 7. Okay, still we have problem because 5 pi by 7 is not in the range of minus pi by 2 to pi by 2. But I know that sine of theta is equal to sine of 180 minus theta or sine of pi minus theta. So if I leverage that, I can write it as sine inverse of sine of pi 180 degrees or pi radians minus 5 pi by 7. This is nothing but equal to sine inverse of sine of 7 pi minus 5 pi is 2 pi. 2 pi by 7. So now I can apply sine inverse on this function because the domain is now 2 pi by 7, that is approximately 0.29 pi, which is between minus 0.5 and plus 0.5. So the answer for that is 2 pi by 7. Let's review that again. 33 pi by 7 is not allowed. If you want to apply sine inverse on that, the angle should be between minus pi by 2 to plus pi by 2. Then only we can have sine inverse on that. So I have to modify this 33 pi by 7 to an value to an angle which is between minus pi by 2 to pi by 2, but will have the same value as sine 33 pi by 7. Now first step we made it as 4 pi plus 5 pi by 7. We know that the period of sine is 2 pi. So 4 pi plus 5 pi by 7 is nothing but equal to 5 pi by 7. But still we have problem, but because that is not in the principal branch or principal window. So we know that sine theta equal to sine of 180 minus theta. So I can write it as sine of pi minus 5 pi by 7, that is nothing but 2 pi by 7. So let's go ahead to the next problem. Cos inverse of, same problem here. We know cos should be between 0 to pi to apply cos inverse. So 17 pi by 6, I will write it as 18 pi minus pi by 6. Can I write it? This is nothing but cos inverse of cos of 3 pi minus pi by 6. We know that the period of cos is 2 pi, so 2 pi plus pi minus pi by 6. I can write it as pi minus pi by 6. That is nothing but cos inverse of cos 5 pi by 6. And you can see that 5 pi by 6 is between 0 to 6 pi by 6. That is nothing but pi. So the answer is 5 pi by 6. Now how we have done that? 3 pi is nothing but 2 pi plus pi minus pi by 6, or you can write it as directly 2 pi plus 5 pi by 6. You know that 2 pi is the period, so it's nothing but directly 5 pi by 6. Okay, let's do some more problems, simple problems. Now we have to simplify this. Tan inverse of square root of 1 plus x square minus 1 by x. Whenever we actually get like this, we have to see which substitution we have to use so that we can simplify it. Now we have tan here, so I will go ahead and say that x equal to tan theta. I will say x equal to tan theta. Now what this becomes? This becomes tan inverse of 1 plus tan square theta 1 plus tan square theta minus 1 by tan theta, that is nothing but equal to tan inverse of 1 plus tan square theta is secant square theta. If you take square root, it is nothing but secant theta minus 1 by tan theta. Now I can simplify that. I can write it as tan inverse 1 by cos theta minus 1 by sin theta by cos theta. If you simplify that, this is nothing but equal to tan inverse of 1 minus cos theta by sin theta. I can simplify this further. What I can do is I can write it as tan inverse of, you can see that 1 minus cos theta is 2 sin square theta by 2 by sin theta is nothing but 2 sin theta by 2 cos theta by 2. So if you simplify, you will have tan inverse of 2 cancels, 1 sin theta will go, you will have tan of theta by 2, that is nothing but equal to theta by 2. But what is theta? Theta equal to tan inverse x. So the answer for this is half of tan inverse x. This is nothing but equal to half of tan inverse x. Let's just review that. What we have done, we have substituted x equal to tan theta so that we can change it into secant. That becomes a secant theta minus 1 by tan theta. Now we have converted that into sin into cos, and we have expanded it. 1 minus cos theta is 2 sin square theta by 2 and sin theta is 2 sin theta by 2 cos theta by 2, by which I get tan inverse tan theta by 2, that is nothing but equal to theta by 2, taking into consideration that theta is between minus pi by 2 to plus pi by 2. Now the answer is theta by 2, but theta by 2, theta is nothing but equal to tan inverse x. This gives theta equal to tan inverse x, and theta by 2 is nothing but equal to half into tan inverse x. Let us solve this problem. We have been asked to simplify tan inverse 1 by square root of x square minus 1. Now if we put tan, it may be little bit complicated, so I will try to go for x equal to secant theta, so that this becomes secant square theta minus 1 is tan square theta. Square root will become 1 by tan theta, that is cot theta. I can make it as tan of pi by 2 minus theta, so that tan inverse and tan will cancel out. So I will say x equal to secant theta, then what happens? This becomes tan inverse 1 by square root of secant square theta minus 1, that is tan inverse of 1 by secant square theta minus 1 is tan square theta, square root of tan square theta, that is tan inverse of 1 by tan theta, that is nothing but tan inverse of cot theta, that is nothing but equal to tan inverse of tan pi by 2 minus theta. Now tan inverse tan will cancel out, we will have pi by 2 minus theta, that is nothing but theta. We know from this theta equal to secant inverse x. So the answer is pi by 2 minus secant inverse x. So what we have done? The substitution is important. In the earlier case, we have taken substitution as x equal to tan theta, because you can see that's the only identity, 1 plus tan square theta equal to secant square theta, which can help you out to simplify it easily. Whereas here you see that secant square theta minus 1 equal to tan square theta is going to help. So if you put x equal to secant theta, we can simplify it and you can get pi by 2 minus secant inverse of x. We'll solve some more problems in the coming videos. Thanks for visiting. Bye for now.